Welcome back, and 21st lecture now. So, we are done more than halfway, and it is a good time for you to check what are the new things you have learned. Quick recap, you now understand, you should be understanding surface tension in much better way. You should not be wondering looking at those beautiful tall buildings, skyscrapers in all the megapolis cities in India now. You now understand that they contain some self cleaning coating. You should also look at a compact disc or a DVD and should realize why it shows rainbow color. So, I am assuming that many of you knew all this before, but I am sure some of you have learned, because that is my experience with the undergrad and the postgrad students where I teach at Kharagpur. There are in fact more interesting phenomena which you can explain with what we have learned. These can be bit of brain twisters. I am just placing them, you just start thinking. One of the things most of you have seen as a child is that beautiful soap bubbles that float around freely, and what you had to do is that you had to add a bit of soap into water. You can never have a soap bubble like thing, and as a term is soap bubble, you can never have a pure bubble with water. Now you know what is surfactant. So, why you need that bit of soap solution, a bit of soap in that solution. A second question you may try to look into, and even if you Google it, I am sure you will get an answer which will be pretty simply understandable to you, is that if you do shampoo of your hair, you tend to see that your hair has become very fluffy. Why does that happen? What really makes it like that? And in fact, if you are searching for an answer to this question, why don't you also try to find out what is the role of a conditioner, because for the last 20 years or so the Indian market is completely filled up with shampoos which comes along with conditioner, and which in fact leaves a hair that is properly cleaned, but that is a bit manageable than a shampoo which does not have a conditioner. So, why don't you try out what these are? In addition to this, you now also know that your latest tablet or your PC or your laptop, why its clock speed or the processor speed is much faster than the one you had seen at your home or you had 4 years back. And stop admiring great progress by computer scientists. In fact, it is the material scientists who are doing all the great work, because you now know that this progress is entirely due to progress in photolithography, right? And you also understand now why on a beautiful rainy afternoon, if you are lucky to see raindrop dropping over a lotus leaf and you see that it is rolling away, you now know that in fact the wetting state on the lotus leaf surface is gassy. And when you also see a beautiful rose which has a drop of water sticking to it, irrespective of whether you turn it up and down, you in fact know that the surface has very high hysteresis, and therefore the water does not get dislodged. So, I am sure you are enjoying this course, which and I'll be more keen to really hope that you have learned something new, and that's the most important thing to me, is to learn new things and then try to somehow use your knowledge in trying to understand and explain things that you see around you. So, let us move on and continue our discussion on soft lithography. This is the 4th lecture on soft lithography, overall 21st lecture now. And if we are back to this particular slide, which acts as a very good guide, in fact, I love this classification. You now know an IL, sorry, forgot to turn on the pen, old people always tend to make mistakes. So, you now know nano imprint lithography and you now know replica molding. What about the other techniques? Of course, all the techniques we have talked so far, they are able of creating topographic patterns, right. Next, what we discuss is micro molding in capillaries, and what you do is it in some ways tries to eliminate some of the problems that are being faced, let us say in nano imprint lithography. It is a very elegant technique but honestly speaking not very effective. It has certain advantages, certain special capabilities which no other technique can offer, but when it comes to routine patterning, I am afraid nano imprint lithography is far more popular. So, what you do is you tend to realize that couple of major problems of nano imprint lithography is you are using a rigid stamp, therefore, stamp release is a problem, and also you are trying to pattern a very high viscosity layer, a molten or a softened polymer film straight away. So, the viscous stresses, firstly you need a high force to do the deformation, and secondly it also leads to very high level of residual stresses. Mimic, what you do not start off with a film, you simply take a stamp created by replica molding. So, this is now flexible, and you, since it is flexible, you simply bring it in conformal contact with the substrate. So, you see if you have a grating pattern stamp, on one of these sides it actually makes zillions of micro channels. I have limitations, and therefore, what I have shown is only a few of these structures, but you can imagine that if the periodicity of these patterns is let us say 1 micron, and your stamp dimension is let us say 1 centimeter, how many of these channels you make. What you do now is you take a dilute solution of the polymer or the material of which with which you would like to create the structures, and simply dispense it at one of the open end, right. Now, if the stamp wall is wettable, and which you can always do by controlling the surface energy, maybe I will give you some recipes how to do that later. What will happen? There will be capillary driven flow along each of these capillary micro channels, and as a result the liquid meniscus will move. So, eventually all you need to do is let the solvent evaporate, and then what you get is you get strips of this polymer or the soft materials along the contours of the stamp. Remember, the stamp is a flexible stamp, therefore, you can very easily. So, your problem of coating the stamp with a release agent, then removing it, which has been encountered in NIL, is gone. You do not need to heat it up in NIL like NIL, so that problem is gone. You also do not require to apply any external pressure, so that problem is also gone. So, this is what is mimic. Also, if you look very carefully, this method is straight away microelectronics or IC fabrication compatible, because in principle if your mimic is well executed, it does not leave behind a remnant layer like nano imprint lithography. Why? Because over these areas the stamp was in conformal contact with the substrate, and therefore, it did not allow the polymer to get deposited. In reality, this is in fact a problem. Often this liquid leads to some bit of flooding, and there is a buoyancy force that lifts up the whole stamp. So, that is a problem, but in principle you can do that. Again, such a simple technique originally published in Nature in 1995 by Whitesides. There are, however, despite all the elegance of the technique, there are certain issues. One of the issue one needs to understand is that you are replicating a dilute solution, or the capillary flow is with a dilute solution, and so eventually when the solvent evaporates away, you never get a structure with the polymeric material that whatever, irrespective of whatever I have drawn, that corresponds to the full cross section. So, if this is the cross section of one channel, let us say, you are very likely to get some structure like this. Why this, even this may or may not be there, this depends. I mean, this is sort of a indication that the stamp wall is weighted well, but you may not have this, but you may have some shallow structures. Why does this thing happen? Because during the capillary driven flow, as shown in this particular step, the flow is taking place with a dilute solution, right, and therefore, the channels are filled with a dilute solution, which is the case in fact in NIL. So, once you feel that the capillary dynamics is over, and eventually the solvent evaporates away, there is going to be significant loss in dimension because of the shrink, because of the evaporation. The other major problem is, I will not go to the mathematical formulation, but one can get this formulation pretty easily, the capillary driving force drops away as you go deeper into the channel. So, after a certain point the velocity of mold filling becomes very less, and therefore, towards the edges you often see this type of incomplete structures taking place. There are some mathematical formulations, but I will probably, in fact, this equation shows why the velocity drops as you go along the capillary channel. But however, there are certain advantages of mimic which no other technique can match, and that is something I said, that most of the soft lithography techniques have amazing capabilities which cannot be matched. Look at this SEM picture very carefully. You are seeing two stripes, but what is important is that they are not made of a polymer, they are made of a layer of colloids. That is the advantage, because mimic does not require existence of a mimic does not require a pre-existing film, right. It is a capillary driven flow, and what restricts, instead of a polymer solution, if you dispense a colloidal suspension, the liquid will anyway flow due to capillarity, due to preferential wetting, and along with that the colloids will go on filling the molds. So, that is exactly what is shown here, and this capability is cannot be done or cannot be replicated by any other soft lithography technique. Earlier in the context of micro lens projection lithography, I gave you an example that you can spin coat colloids on a flat surface and they form beautiful hexagonal close pack structures. But even if you start off with such a hexagonal close pack structure and try to pattern it, you can never get neat structures which are only made of colloids, right, by nano imprint lithography. So, this is one of the strengths of mimic. One major limitation of mimic, of course, is that every area below your stamp. So, we have been talking only about gratings like this, which is fine, but any complex geometry, the entire pattern has to be connected to the sides, so that so that the solution can reach that area. That is one of the limitations, particularly you now realize that mimic does not work well for patterning over large area, because the capillary driving force sort of drops too drastically. One of the sort of a quick remedy of mimic that was suggested a bit later was SAMIM, solvent assisted micromolding, and here is something that I would like to remind you. I warned you that soft lithography has too many names. So, do not get perturbed or bothered too much about this name thing, but please try to understand. For example, this particular method I am talking now, this SAMIM, solvent assisted micromolding, it does not figure in my original list. The reason is it is too close to mimic. It sort of circumvents some of the elementary problems of mimic, some of the basic problems of mimic, by taking some clue from nano imprint lithography and other techniques which starts off with a pre-existing film. So, what you do here, instead of mimic, where you start off with a bare substrate, there is no film, you are back to a spin coated film in SAMIM, right, just like nano imprint lithography. You do that. What you do, you take the stamp, wet it in a solvent of the film, right, you try to wet it in the solvent of the film. So, as you place the stamp on the film, locally the solvent that comes along with the stamp sort of reduces the viscosity of the film locally in the periphery of the stamp, and since and in presence of the stamp, due to capillarity or due to any force you are applying, the polymer sort of reorganizes along the contours of the stamp pattern, and you get some nice patterns. When the stamp is coming, suppose this is the stamp you are bringing in, this is a wet stamp. So, the stamp itself, the wet stamp itself is bringing the solvent. So, therefore, the problems are associated with mimic, that the due to capillarity, liquid does not reach at the center of the stamp and at long distances from the edges, these are completely eliminated. But honestly speaking, as a concept, this is very good, because you still do not need any thermal cycling, you do not need to apply high pressure, but then pattern uniformity control is a critical issue, because over the central areas, how does the solvent evaporate away after patterning, I mean the rate of evaporation from the peripheral zone will be much faster as compared to the core area, and if the core area contains solvent and you withdraw the stamp, what in fact happens is you are leaving behind a patterned polymer layer whose viscosity is too less, which is too fluidic. So, because of surface tension issues, Laplace pressure, it tends to flatten out. So, the problem again remains, mechanism is different as compared to mimic. Mimic areas deep inside the stamp, because of very sluggish capillary dynamics, patterns do not tend to get replicated. Samim again, often it is seen the central locations areas away from the periphery, it is nearly flat, but it is not that they were deprived of solvent like mimic, but it is simply because of the fact the solvent evaporation rate is too slow there, and if you do not adjust your stamp withdrawal time very carefully, you might end up doing something where you have removed the stamp, but still it remains too fluidic and eventually it flattens out due to Laplace pressure. So, all these things needs to be understood, and that is one of the reasons why soft lithography is preferred by researchers. So, because there is a lot of very rich science and more than so there is a lot of stuffs to sort of examine, lot of phenomena that is occurring, capillary dynamics, Laplace pressures, stabilizing effect, etc., which are very interesting, but for a bulk fabrication or rapid fabrication, these issues might be very difficult to control to lead to reproducible structures. One very elegant improvement over both mimic, SAMIM as well as NIEL is the development of capillary force lithography, CFL. And I must very proudly point out, well, here I am not acting as an Indian, but I am acting as an Asian, that this capillary force lithography was not developed, neither developed by Stephen Chow nor by Whitesides, but it was developed in Korea by Professor Hong Lee, a very eminent scientist in this particular area. So, what it does, it sort of takes the best practices across the different techniques. It does the thermal cycling or the solvent vapor exposure like nano imprint lithography, but it does not take a rigid stamp, it takes a soft stamp, so that you can peel it off. The problem associated with the mold removal as observed in NIL is not dominant. What you do is you simply bring a stamp and leave it in contact with and this pressure, though it is written, it is very less, very low pressure, even the pressing with your thumb might work. You bring the stamp in contact with the film, which is either heated or it is exposed to its solvent vapor. Both has its problem of mismatch in coefficient in thermal expansion or swelling, as you know, because if you expose to solvent vapor, the problem is the film swells as well as the stamp swells, because it is a Silgard stamp, right, and then you do nothing. In fact, the pattern replication in CFL is again by capillary dynamics, but unlike in mimic, sorry for the bad quality of drawing. So, this is the capillary driven dynamics in mimic. I am just showing one of the channels. So, it relies on the capillary driven flow along the length of the each of the channel. So, firstly it is the along the mold filling is along the length and a dilute solution. Instead, what happens in CFL is it relies on capillary dynamics of the polymeric film, softened polymeric film, which is in a liquid form along the height of the channel. So, immediate consequence is this height is few hundreds of nanometer or maybe few micron, and this is centimeter, at least millimeter. So, you are reducing the travel path of the fluid by capillary dynamics, and therefore, the problem that we had in mimic, like the velocity, capillary driven velocity becomes too less and mold filling does not take place, all those problems are eliminated. Yes, it is quite obvious that if you let the stamp remain in contact with the softened polymer layer, the viscosity is very high, because there is no dilution, unlike mimic or samim. You do not bring in any solvent, you just rely on the fact either you expose this film layer to solvent vapor, or you do simply heat it up beyond its glass transition temperature. So, it is a slow process, but then the path that the polymer meniscus will have to travel is also less. So, you give some bit of time, you just need to optimize it, might be few hours, few couple of hours, and you get perfect mold filling. What are the advantages? You do not apply pressure like NIL, you do not use a rigid stamp, therefore, the issue associated with stamp removal is completely eliminated. You can simply peel off, because you are using a crosslink seal guard stamp. The structures you see at the pattern replication dynamics, the meniscus rises along the stamp walls, unlike in nano imprint lithography, where the liquid adjacent to the stamp wall was actually going down. So, therefore, the residual stresses are almost 0. Of course, there are issues, as I mentioned, that you need to liquefy the film. So, either you need solvent uptake or you need thermal cycling. So, therefore, the coefficient of thermal expansion mismatch or solvent vapor induced swelling. These are important issues, but there are many advantages that CFL offers, and CFL has become a very popular nano patterning technique. It was developed around early 2000. It is indeed a very popular nano patterning technique, and lot of people implement it in the lab scale. So, because unlike nano imprint lithography, it almost requires nothing. Even you do not require a clean room, because unlike NIL, you are not using a rigid stamp. So, even if there are some dust particles here and there, what will happen? Suppose I am talking about a very practical situation. You have a film which is dusty, here is a dust particle. So, as I told that if you want to bring in a NIL stamp, it will simply break, because you are applying a pressure, it will form a couple, etc., etc. Here simply what will happen is the stamp will, this is of course patterned here, will go in conformal contact and it will simply bypass this area. So, after you remove the stamp, yes, dust has caused damage no doubt, but this area of the film will be neatly patterned and other areas will be neatly patterned. So, for many applications, if you have patterns over some few centimeter square, few millimeter square is large, in fact, in the context of nano patterning, this serves your purpose. So, CFL is indeed an excellent technique. CFL also does not guarantee that your patterns are remnant layer free. So, in order to create self standing structures, you need to do some sort of etching. So, in fact, it is interesting to note that both CFL and NIL lead to almost identical structures, and both these structures, when these structured films are subjected to or liquefied, or they are heated up, or they are exposed to solvent vapor, they tend to flatten out. And the reason you now know, because a structured or a patterned film has high surface energy and which is not desirable. So, they undergo slumping. I have a question that is bit, you can consider it to be bit of a brain teaser. Before I go to that, let me also highlight one major advantage CFL has. Remember, it is using a flexible stamp. NIL is again stuck up like photolithography because it uses a rigid stamp, and one key advantage is since it's using a flexible stamp, it can now pattern films coated on curved surfaces, and this is a non-trivial capability. As I mentioned, every technique, almost every major soft lithography technique has some major advantage or key advantage or the other, and this is indeed one of the major capabilities of CFL. Of course, mimic and all other techniques that use a flexible stamp can in principle be used for patterning curved surfaces, but CFL sort of does it very elegantly. What you see here is another special case that you do multiple CFL with a grating stamp and you can create 2D structures. One quick question that I would like to have is related to this. In fact, if I sort of give you a profile of a film which you know is a perfect negative replica of your stamp, can you identify what was the patterning technique, whether it has been made by, particularly I would say whether it has been made by CFL or NIL. Well, be practical, so do not give me an answer like I will measure the level of stress and come out with a solution. That is not doable. So, honest answer is that you really do not know. One thing is you can destroy the film, probably if you heat up the film, both the films, maybe you take two films identically structured, one has been made by CFL, the other by NIL. Probably the NIL film will undergo slumping faster because the residual stresses are more. Important thing to remember that if your pattern replication is perfect, you can't identify. But suppose you have tried to pattern and you have stopped at an intermediate level, then in fact very nicely one can look into the profile of the partially replicated patterns and can say what is the pattern replication mechanism. If I now draw this, I am sure you can correlate to the mechanism of CFL I was talking 2 minutes back. So, this will be the structure intermediate patterns in CFL. In contrast, the partially replicated pattern in NIL will have profiles like this, because in NIL the rise is not along the walls, it is actually through the center. So, these are, I mean, you can in fact do that because you know that the advantage with working with a glassy polymer is the moment you reduce the temperature, the dynamics freezes, the structures freezes, and you can, as you will see a few lectures later, you can use the wonderful instrument called atomic force microscope, AFM, which I have promised that I will teach you in great detail, and you can identify and see all this. So, with that I stop this lecture, and I think I will need 2 more lectures on soft lithography, or maybe 1 more lecture to wrap it up and then move on to atomic force microscope. Thank you very much.